anybody by raising your hand. Yeah.
Well, at the end of the problem, it's telling us what our main goal is. We're trying to figure out how much money it'll cost in order to fill up that acquired space.
Absolutely. So, what he said is, the goal is definitely to figure out the cost. And what unit are you going to use? Or try to find? American dollars. Wonderful. All right. So, what might be important to help you along the way? Okay, we'll get to the diagram in a moment. Yes?
The measurements of the burden.
Absolutely. So it's 15 feet 8 inches, 6 feet 10 inches, 3 inches deep. What else might help us? Yes?
How much each bag is going to cost?
Absolutely. So we know that one bag is $7.25. What else might be helpful? Yes?
How much area, just how much area they cover per bag?
Absolutely. So we'll definitely. Anything else that will be helpful for us in this problem?
Kilograms of soil.
Yeah, so we know that kilograms of soil is related to cubic centimeters. Then we know all of this extra business. So, lots of numbers we can pull out to help us think about this problem. So now I'm going to attempt to draw a picture, no promises it'll look good, of what our garden might look like. So we have this situation where we have 15 feet, 8 inches on one side, 6 feet, 10 inches on another side, and there's a 3-inch hydrant. So we're trying to figure out the dirt in terms of this space. So, at this point, step 1 is done. We figured out what's important, we figured out the goal, we've drawn a fun picture. Now step 2 is what? That is the answer to step 2, absolutely. Step 2, we're going to describe the chemistry, and which of the 2 chemistry principles will be most important that you've learned up to this point? What type of problem is this? This is a unit conversion problem. Eventually there'll be all sorts of other problems, but for now we're just going to say this is a unit conversion problem. A little bit of a break at this point, and we're going to give you guys a way to work through unit conversion problems that I personally recommend. It will increase your accuracy as well as your efficiency in terms of unit conversions. So, highly recommended that you do this process. You choose not to, that is fine, but I think it'll help. So let's imagine that we are trying to figure out in a separate problem the number of minutes in 1 year. And let's define 1 year, for instance, as being 365 days. Are there any other relationships that might help us as we do this unit conversion problem?
Hours in a day.
So hours, absolutely. We can say 1 day is 24 hours. Anything else that might help us?
Minutes.
Minutes, wonderful. We know that 1 hour is 60 minutes.
2 weeks in a year.
So we certainly could do that, but we already have a connection of years straight to days, whereas 52 weeks in a year would take us away from that relationship. So when we come up with relationships we could use, some of them will be beneficial, some of them will not be, and then it'll be a matter of putting them in order and figuring out which ones are helpful. So, what we're going to do in this problem is we're going to set the units up on these train tracks to cancel the unit we had previously and work toward a unit that we want. So, what relationship could we use to cancel years and move toward something closer to minutes? Yes.
So underneath the line, so after you the horizontal line, underneath it you can write 1 year and then top equivalent to 165 days, and it'll cancel out the years.
So let's take a look at this. So what he said is, let's put years on the bottom, 365 days on the top. Agree, disagree? Why is this a good setup for this particular problem?
Because you want to cancel out the year.
We want to cancel out the unit that we had previously, and putting them opposite of each other allows us to do so. Year divided by year makes it go away. So now we're in days. What relationship is available to us to move away from days and toward a better unit?
1 day.
1 day is equal to 24 hours. Where am I going to put the day, on the top or the bottom?
Bottom.
Yeah, let's go ahead, put 1 day on the bottom so that it cancels day on the top previously, and we'll put 24 hours on the top. Finally, we're going to use our 1 hour to 60 minutes. Which one am I going to put on the top?
60 minutes.
60 minutes. We'll put 60 minutes on the top because by putting 1 hour on the bottom, it allows it to cancel. All right. So you multiply this out and you get 525,600 minutes. And my question for you is, how do you measure a year? Nobody? Of course, anybody. No one likes musicals. I'm looking forward to it. Everyone, you need to listen to the music from Rent right now. Okay, so that is one relationship we can think about. Another one we can think about is, let's imagine we have a truck, and this truck bed is 1.5 cubic yards. We have this bed, the back of the truck, and it's 1.5 cubic yards. Let's think about the fact that a yard cube is like massive, okay? And let's imagine we wanted to figure out how many cubic feet is in our truck bed. Is there a relationship that might help us that we might know if we know the English system? Yards to feet. How many feet are in a yard?
36.
There's 3 feet in the yard. So let's imagine then we set this up. 1 yard cubed is equal to 3 feet cubed. We multiply this out and we get that our truck bed is 4.5 feet cubed. Does this make sense? You're saying no. Why not? So mathematically, I've done something wrong, which we'll talk about in a moment. Let's just think conceptually. We have this yard, 1.5 of them, and what we're saying is 4 of these little foot boxes fit in 1.5 of these boxes. Conceptually, does that make any sense? No. What I have forgotten to do is I need to think about the fact that there are 3 feet in 1 yard, but let's imagine we cube this. We have to think about the fact that we have to distribute the cubed to every aspect within there. So there's not 3 feet cubed in 1 yard cubed. How much is there? 27 3 cubed feet cubed, or in other words, 27. So, something to consider when we do this setup is if we have a relationship where we have a unit that is cubed or whatever, or squared, we can't only cube the unit in our community, we also have to cube the relationship as well. Questions about either of these? Okay. So, back to our